Now, how to calculate the line pack of a gas pipeline? Now, this is a problem. Now, the natural gas pipeline is 50 miles long and has an inlet pressure of 1200 psig and outlet pressure of 890 psig. When transporting 120 million standard cubic feet per day, the base pressure and base temperatures are 14.7 psia and 60 degrees Fahrenheit respectively. If the pipe is the nominal size of the pipe is 16 inches and 0.375 inches wall thickness. Now we are asked to calculate the line pack assuming an average gas temperature of 75 degrees Fahrenheit using an average compressibility factor of 0.85. Now, to calculate the line pack, what is line pack first? We now have to understand it first before what is a line pack. So now a line pack is actually the quantity of gas contained within the pipeline under pressure, measured at standard condition, generally 14.7 psia and 60 degrees Fahrenheit, is termed the line pack volume. So now what we want to calculate is the line pack volume. So the line pack, see, having been described as a quantity of gas that is being contained in a pipeline under pressure, and this is measured at standard conditions. So now let's assume this is a pipeline. Now at condition P1 and this is a condition P2. So at this point, this is the pressure of P1. At this point, this is the pressure of P2. So the distance from here to here is given as L. Now the internal diameter, that is what we're using, of the pipe D. Now we have known the internal diameter of the pipe. So now, you know, the pressure here, we don't know the pressure here. Because you see the pressure, we're supposed to use a particular pressure. So now, since we don't know the pressure here, we what we do, there is a formula to calculate the average pressure of gas within this region between P1 and P2. So we now calculate the average pressure within this region. So now that is why in calculating the line pack of a pipeline, the pressure, the conditions of the gas at various points changes. So along the line, now it has different temperatures and pressures along the line. So that is why actually when you want to calculate the line pack, we use smaller distance. Now with that smaller distance, you calculate the line pack at each smaller distance, then you sum them all together to get the line pack of that pipeline. So because you need to calculate the average pressure. Now we also now they have already calculated the average temperature, and also they also have given us the average compressibility factor. Now what is left for us to calculate now is the average pressure. Now and again, for us to do this, now we need to calculate the volume inside this region at standard condition, not at the average pressure and average temperature condition. Now, let's now write down, having understood what the line pack is. Now, let's write the given information. So now the given information is now, they gave us the length of the pipeline, which is 50 miles. They gave us the upstream pressure, which is 1200 psi A. They gave us the downstream pressure or the outlet pressure, which is 890 psi G. Now, we need to convert this to psi A. To convert it, we need to add the base pressure. So we say 120, 1200 plus 14.7. So this will give us what? 1214.7 pxi A. Now, the same applicable to this, you have 890 plus 14.7. So this will give us what? This will give us 90, okay, 904.7. So psi A. Now we have calculated this. This is a given information. We have calculated the absolute pressure. Now we are also given the flow rate. The flow rate of the pipeline. Actually, to calculate the line pack, we don't need the flow rate information. Now, we are given the base pressure, which is 14.7 psi A. We are given the base temperature, which is 60 Fahrenheit. Now, converting the 60 Fahrenheit to Fahrenheit, we have 520 Rankine. So now the nominal pipe size is 16 inches. The thickness, the wall thickness of the pipe is 0.375 inches. Now the internal diameter D of the pipe will now be the nominal pipe size minus 2 times the wall thickness. So we have 16 minus 2 times 0.375. So this will give us 16 minus 0.75. So this should be 15.25 inches. So that is what it will give us, 16.25 inches. Now, we have known the value of our internal diameter D. Now, let's say the volume of the pipeline under condition, under investigation. What's the volume? The volume of this pipeline now from here to here is just, now we calculate it by saying the area, the cross-sectional area of the pipe times the length of the pipe. And the cross-sectional area of the pipe is pi d square all over 4 times what? L. So invariably their volume is pi all over 4 times d square L. Now this is a volume that is contained in that region or in that pipeline, the physical volume of the pipeline. Now, the line pack is to calculate the volume of the gas in that container. Let's say it's a container. In that container in standard condition. So now we have gotten this based on this. And again, we now we know we know the temperature of the gas, the average temperature of the gas, which is what? 75 degree Fahrenheit. And this 75 degree average temperature with 75, we have to convert it to Rankine. This will give us what? This will give us 75 plus 460 equal to what? 535 degree Rankine. Now we have the average compressibility factor is given, which is what? 0.85. Now we need to calculate what? The average pressure. So the formula for average pressure is 2 over 3 times bracket open P1 plus P2 minus P1 times P2 divided by P1 plus P2. Now let's calculate this. So now we have 2 over 3, that is 2/3, times bracket open. The inlet pressure is 1214.7 plus the outlet pressure, which is what? 904.7 minus now 1214.7 times 904.7 divided by 1214.7 plus 904.7. So let's now make use of our calculator to calculate this. We have to divide by 3 times bracket open 1214.7 plus 904.7 minus 1214.7 times 904.7 divided by bracket open 1214.7 plus 904.7 bracket close equal to, so the average pressure is 1067.3 pxi. Now we have calculated the average pressure. So this is a condition. This is a condition of the gas when it is at this volume. That is it. So now we are asked to calculate the volume. The line pack is now the volume of the gas at standard condition. Now let's use ideal real gas equation now, we have P, let me call it, let's say P at standard condition, the pressure at standard condition times the volume at standard condition, divide by the compressibility factor at standard condition, divide by what again? The temperature at standard condition. So this will now be equal to, this one will now be equal to the pressure, this is the pressure at, let me just say, at the, the condition now, let me call it P, condition P, and the volume at the condition P, sorry, divide by the ZP divided by the temperature P. So now we know that means this, now at the standard condition, the compressibility factor is approximately 1. Now, but the ZP is equal to Z, which is 0.85. That is the average compressibility factor of the gas in that is confined in that um, pipe. Now, and the VP is the pi divided by 4 times d square L. Now we are good to go now. Now what we are asked to calculate is this now. Now let's make V subscript B the subject of formula. Now let's go, this down. So now we have PBVB divided by ZBTB equal to PPVP all over ZPTP. Now, this, the line pack volume is this VB. So now let's make VB the subject of formula. To make VB the subject of formula, we have to multiply both sides by the inverse of this and this. Inverse of this pack, this pack. So the inverse of this pack will now be, you have P B V B divided by Z B T B. So when you multiply both sides by the inverse of this, so now you have TB in ZBTB all over PB is equal to P subscript PV subscript P divided by ZP T subscript P times ZBTB divided by PB. So this will cancel out this will cancel out this. We have VP equal to, now bring out the VP. Now we say brackets times bracket open P subscript P divided by ZP subscript P T P times Z B T B divided by P B. Now, since a standard condition ZB is equal to 1.0, now the compressibility factor of the gas at this condition, at the condition of the gas, is ZP, which is equal to Z, which is 0.85. So now we have to replace ZB, which is the compressibility factor of the gas, as standard condition. So a standard condition, actually the ZB, the Z is always 1.0, that is 1. So we replace it with 1. Now we are also going to replace VP to be equal to pi divided by 4 times d square L. Now let's go back. See, VB is 6. Now so we're going to replace this with this. So that means VB, that is the line pack volume, is equal to pi all over 4 d square L times what? P subscript P divided by, now this P subscript P, we will exchange it with average pressure, the average pressure of the gas, because the condition of the gas is at the average pressure. So now the ZP, the subscript P, is our Z, which is the average compressibility factor. Now, and the temperature of the gas, the temperature of the gas is given, the average temperature of the gas, which is the condition of the gas at VP. So that is the temperature of the gas at that VP times what again? The ZB is 1, so we're not going to bring it over. So we have TB divided by PB. Let me see. Correct. Now we are here now. We know. Now let's now solve for VB, and the VB should be in feet cube. The value of VB should be in feet cube. So for us to solve this, we say this is equal to pi all over 4 times the diameter of the pipe is in inches. So now we have the internal diameter of the pipe, which is 15.25 inches square. Now we need to change this inch square to feet. So times, so what we're going to do, we multiply by what? Now we know 1 feet is equal to 12 inches. So since this is square, we square it. So that is it. Now times, we have the 50 miles. Now our volume should be in feet. So we need to change this mile to what? To feet. So we have 502 5,280 feet equals to what? 1 mile. Now, times, now we have this to be what? 1,067.3 divided by the Z is 0.85 divided by the temperature, which is 535. That's the average temperature of the gas times what again? The base temperature and the standard condition. So the base temperature, which is what? 520 divided by the base pressure, which is 14.7. Now let's work it out. Let's calculate this to see what is the line pack volume. So to do that, you say pi divided by 4 times. You can make use of your calculator to punch it out so that you also cross-check the answers. Now times 15.25 square divide by, got 12 square is divided by 144 times 50 times 5280 now times 1067.3, that's our average pressure, divided by 0.85 divided by 535 times 520 divided by 14.7. So we have 27 you have 27,801,665, let's say 0.5 cubic feet. So this is our final answer. We can invariably say it is 27.8 times 10 raised to 0.6 cubic feet. Let's say standard cubic feet, because that is what it is, standard cubic feet. So, but this is in a standard form. So this is the final answer. Thank you for watching to the end. This is the final answer. Thank you for subscribing. Thank you for subscribing. Also do well to also, if you have not subscribed, do well to subscribe so that when next I make new video, you will also be the first to watch. Thank you and God bless.